Today we're going to look at the first part of section 1.4 for Algebra 2. We're dealing with solving equations. Our objective today is to solve equations and to solve problems by writing equations. So our first definition, an equation is a statement that two expressions are equal. An example of that would be something like 2x plus 5 equals y. All right, that's an equation. We are setting two different sides equal to each other. In order to solve equations, we need to refer to the properties of equality. The first property is called the reflexive property. It just says that A equals A, so a number or a variable equals itself. The symmetric property says if A equals B, then B equals A. We can turn them around. They're the same. So again, if I said 3x plus 5 equals 10, I could rearrange that and say 10 equals 3x plus 5. They are equivalent. The transitive property says if A equals B and B equals C, then A has to equal C. So if these two things are equal to the same value, then they have to be equal to each other. Our substitution property says if A equals B, then we can replace A with B and vice versa. So if we know that A and B are the same, we can interchange them. The other four properties tell us what we can do to two values and that would keep them equal. So if we start out with A and B being equal, this one says I can add the same amount to both sides and they're still equal. This one says I can subtract the same amount from both sides and they're still equal. Same with multiplying and same with dividing. As long as I'm doing the same thing to both sides, if they started out equal, they will remain equal. All right, so solving the equation is finding all the values of the variable that make that equation true. In order to do that, we're going to use inverse operations to undo the equation. For example, we can subtract to undo adding. So we have four examples here in this first problem that just illustrate those last four properties. So if we are looking at x minus 8 equaling negative 10, we can undo subtracting 8 by adding 8. And as long as we do the same thing to both sides, they are still equivalent. So now we have x equaling negative 2. For question B, we have 12 times c equals 18. We can undo that by dividing both sides by 12. And now c would equal 1.5. Part C, x divided by 4 equals negative 1/2. We can undo division of 4 by multiplying both sides by 4. And negative 1/2 times 4 would give us negative 2. And our last one here, we have 2y minus 1 equals 5. We can undo the subtracting 1 by adding 1. And we can undo multiplying by 2 simply by dividing it out. All right, so let's look at a few more involved examples. Here we have negative 2 times the quantity y minus 1 equals negative 16 plus y. Our first step would be to distribute this negative 2 so that we can eliminate the parentheses. So we're going to have negative 2 times y, and negative 2 times negative 1 gets us a positive 2. Now you'll notice that we have variables on both sides. We want to get all of the variables to the same side. It really doesn't matter which side you move them to. So in this case, I'm going to subtract this y over here. Now I have negative 3y plus 2 equaling negative 16. I can then subtract the 2. And keep in mind that when you're solving an equation, you're wanting to kind of go in reverse order of operations. Negative 3y would now equal negative 18. And now I can divide out the negative 3. So I end up with y equaling 6. Okay? Our next example, again, we have some distributing to do. We're going to distribute the 3. 3 times 2x would be 6x. 3 times negative 1 is negative 3. Oops. Then we have negative 2 that's getting distributed to both of those. So negative 2 times 3x would give us negative 6x. Negative 2 times 4 would be negative 8. And now we have some like terms that we should combine. In this case, we have 6x minus 6x, which is going to add up to 0 x's. So we end up with this negative 3 minus 8, or negative 11, equaling 11x. And now we can get x by itself by dividing out our coefficient, the 11. So we end up with x being negative 1. All right, sometimes we actually have to set up the equation. It says the map shows distances between towns in miles. You and your friend drive together from Newtown to Essex. You drive first for a total of 40 miles. Then your friend drives 1.5 hours to reach Essex. What is your friend's average rate? So we are starting out here, and we want to end up here. We can look at the total mileage. This map is showing us that it is 46 miles from Newtown to Dayton, 44 from Dayton to Highville, and 37 from Highville to Essex. So our total distance that we have to drive is going to be 46 plus 44 plus 37. Now, we are splitting that up. It says that we drive the first chunk. All right, so we're going to drive 40 miles. That means we're not quite to Dayton, since it's 46 miles to Dayton. So we're going to stop about here, and then our friend is going to start driving. Okay, so we're going to drive 40 miles, and then we're going to switch, and your friend is going to drive the rest of it. Okay, and the rest of it would mean all of this added up together. Okay, those two sides are going to have to balance. The part we drive, the part our friend drives, has to equal the total. Okay, so what do we know about the friend? It says our friend is driving 1.5 hours. We don't know how fast they're driving, but they have to, in the 1.5 hours, they have to cover that total distance. So we used up 40 miles. Our friend is going to drive 1.5 hours times some speed to cover the total distance. Okay? Remember, distance equals rate times time, or speed times time. So we know the time is 1.5 hours. We just don't know how fast they're driving. But they do get us, our friend gets us to Essex, so we have to cover the whole mileage. Okay? 46 plus 44 would be 90. Plus 37 would be 127. All right, now we have a basic equation. 40 plus 1.5x has to equal 127. We're going to solve this by subtracting 40. (127) minus 40 would be 87. And then we're going to divide out our 1.5 to get our speed. In this case, our speed would be 58 miles per hour. All right, so sometimes equations have a single answer like the ones we've just been solving. Sometimes equations have no solution, where no value makes the equation true. Sometimes all values make an equation true, and we call these identities. So we're going to look at a couple more examples here where we might run into this issue of sometimes or always or never being true. So always true means you have an identity. It doesn't matter what your variable is, it will always work. Sometimes is the type that we've been solving, where you get one solution. And then never would mean there is no solution. And remember, you can use that symbol, the 0 with the slash through it, for no solution. So the first one says 11 plus 3x minus 7 equals 6x plus 5 minus 3x. We're going to combine like terms. We can put the 11 and the negative 7, or the 11 minus 7 together to be 4. We can combine the 6x with the minus 3x to be 3x. And now when we try to get the variables to one side, we can subtract 3x over, but what happens is all of our x's completely disappear. And we end up with the statement 4 equals 5. So when your variables disappear, you have to look to see if you have a true or false statement. In this case, we have a false statement, which means it is never true. There is no value for x that I can plug in that would ever make that work. Our next example, we have, again, some like terms to combine. 6x minus 2x would be 4x. On this side, we can combine our constants, the 4 and the 1, to get a 5. And now if we combine, or excuse me, if we try to get our variables to one side, they still disappear, but we're left with the statement 5 equals 5, which is true. 5 does equal 5. That means we could have plugged any number in for x and it would always work. All right, so what I'd like you to do is pause the video for a minute and try these next two and then turn it back on and check your answers. All right, for this one, we are going to do some distributing to get rid of our parentheses. So 3 times x and 3 times negative 4. On this side, we're going to distribute the 2, so we get 4x minus 12. Combining our like terms, 2x plus 3x would be 5x. Over here, combining our like terms, 4x plus x again would be 5x. Getting our variables, sorry, I switched that to a plus 12. It should be a minus 12. Getting our variables to one side, we could subtract 5x from both sides, but that makes our variable disappear. And what we have left is negative 12 equals negative 12. Since this is a true statement, we're going to say this is an always situation. There's an infinite number of values that we can plug in for x that would make that work. For this last one here, combining like terms, 7x minus 4x would be 3x. On this side, combining like terms, the 12 minus 8 would be 4. Getting variables to one side, we're going to subtract our 3x's. And we are left with the statement 6 equals 4. Again, since we have a false statement with no variables left, we say no solution. There's nothing we could have used for x that would have made that true. No solution means it's never going to be true. All right, we're going to stop there for today and check your Schoology page for your assignment.